Good day. So let's do some simplified expressions with exponents. You see here we got a bunch of rules for exponents and how they work. I'll briefly go over these with you, maybe show you guys a couple examples of how these work. So this first one you got here, that if you have a base number a, so the base is still the same, and these are being multiplied together, that what you do is you add the two exponents. Okay, the second one, what you got here is you have a base number being raised to some number, and that entire expression is being raised to some other number. What this is saying is that you basically multiply these two exponents together. Okay, the third rule is if you have some number being multiplied by some other number, and that entire expression is being raised to some number, that you kind of distribute this in. So here's what you get. You get a to the n times b to the n. Okay, real quick, the fourth rule here, that if you have a fraction and it's being raised to some number, that means that the numerator is raised to that number and the denominator is raised to that number. But remember, it has to be within these parentheses. Okay. Okay. Next rule: any number raised to the zero power equals 1. So long as that number doesn't equal 0. So in other words, you can't have 0 raised to the 0. You can't have 0 raised to the 0. Okay, you can't have that. So that's all this is saying, that a cannot equal 0. Any number raised to the 0 power equals 1. Okay, next problem, or next rule is that anytime you have a negative exponent, it basically means you're going to switch it back and forth underneath the this division sign. So like fractions, etc. If you have a negative number, that means it goes down. Any negative number in the denominator goes up. So you see that here you have a to the n, here you have negative. So these two expressions are equal. So if you have a negative, it just means it goes up, or negative here, it goes down. Same thing with a fraction. If you have it raised to a negative number, it's basically going to flip that entire fraction upside down. Here it is written another way. So here we have some base number, and we're going to, give that a negative exponent. So that basically means that you're going to give the reciprocal of that number. You're going to put it 1 under a to the n. So it's basically going underneath. Same as we're doing up here. It just goes underneath. Okay, and the last rule: if you have the same base but two different exponents here, that you're going to subtract them. So it's kind of the opposite of the first rule, where we're multiplying, they're being added. Here we're dividing, so they're being subtracted. Okay, I'm going to give you guys quick examples of each one of these properties, and then we're going to get into doing some problems, some simplifying. Okay, so for the first one, here's a quick example. So here we have the same base, 2 and 2. Similar to here, we have the same base, a and a. So the bases are the same. So what you're saying is that this is 2 times 2, right? There's your 2 squared, 2 times 2. And then you're multiplying that by 2 times 2 times 2. There's your 2 cubed. And what you get, if you count them out, 1, 2, 3, 4, 5. So you got 2 to the 5th. So that's going to be 2 times 2 plus 3 is also 2 to the 5th. Okay, so there it is. There's your m plus n. There it is right there. Okay, pretty simple explanation of how that first one works. Okay, the second one, let's say you have 2 squared, and that is being cubed. Okay, so you have 2 times 2 times 2 times 2 times 2 times 2. There it is. There's your cubed. There's your cubed. 1, 2, 3. Right? 2 squared, cubed. There's 3 of them. So what we're saying is that this is 2 times 2 times 2 times 2 times 2 times 2. What does that equal? 2 to the 6th. Okay, so now with our shortcut or with our rule, we're saying that this is 2 times 2 times 3, which is also 2 to the 6th. So here's our rule. Here it is, kind of longhand method. Okay, and then here's our rule. So you see that they're the same. You get the same answer. So here's kind of our proof of why this works. Okay, so our next one is this guy here, this a times b raised to the n equals a to the n, b to the n. So what you have is 2 times 3. That's going to give you 6 squared. That equals 36. Okay, there's if you don't use the rule. Then if you use the rule, another way to say this is 2 squared times 3 squared. Okay, this 2 squared times 3 squared, there it is, the rule here. We're just kind of distributing this power in there. So we know 2 squared is 4, 3 squared is 9, so 4 times 9, that also equals 36. Okay, so there it is, kind of the proof of the way this works here. Okay, this next one, over here we got the fraction being raised to some power. Okay, we're saying that that's going to be the numerator raised to the power and the denominator raised to that power. So first let's just do the normal way. So 10 divided by 5 is 2. 2 squared equals 4. Okay, now with our rule, we're saying that this is going to equal 10 squared over 5 squared. So that's going to be 100 divided by 25. That also equals 4. Okay, so here's your proof of how the way that works. Okay, so there's that. Okay, the last one I want to prove to you is this. Any number raised to the 0 equals 0. Or excuse me, any number raised to the 0 equals 1. So here we have 2 cubed divided by 2 cubed, and if we use our rule earlier, if we use one of our rules, we know that this is going to be 2 to the 3 minus 3, right? So that's equal 2 to the 0. So what we're saying is that this is 2 cubed is 2 times 2 times 2 divided by 2 times 2 times 2. Okay, that's 8 over 8. We know 8 over 8 divided by 8 is 1. Okay, so we use rule. Oh, I guess I haven't taught you this rule yet. We'll get that one next. This is the one where you're dividing. If you're dividing, you're subtracting, which was the opposite of this one I showed you. So if you're dividing, you're subtracting. So you can see that this is the reason why any number raised to the 0 is going to be equal to 1, because of this rule here. Okay, that one that I just showed you was this one here where you're dividing. So this is the rule that we get to use for any number raised to the 0 equals 1. Okay, so here's this rule. I don't really know how to prove it, but just kind of show it to you. So this is going to equal 7 squared over 7 cubed. So basically you're just flip-flopping these. If you got a negative exponent, you're just flip-flopping them across the this division sign here. I guess the way to prove it, go ahead and try it in a calculator, and you'll see that you'll get the same kind of answer. Okay, so here's what this one would look like if I have this next one here. Basically, if you have a negative exponent and you have a fraction, that you just flip it upside down. Okay, that's all it is to that. Okay, this next one here, if you have anything raised to a negative number, you're just going to say that's 1 over 2 squared. So you just basically, it's the reciprocal. So that reciprocal just means 1 divided by whatever this is. Take away that negative sign. 1 divided by 2 squared. You just kind of put it underneath one of these division signs. Okay, and the last one. So if I have 2 cubed divided by 2 squared, okay, so that's going to give you 2 times 2 times 2 divided by 2 times 2. Okay, there's your 2 cubed. There's your 2 squared. That means you could cross these out. What we're left with is 2. Okay, now what we're saying is that this also equals 2 to the 3 minus 2, which is just 2 to the first power, which just equals 2. So there it is, kind of the proof of the way this one works. Okay, so there they are, the properties all summed up. Now we'll go through some exercises, kind of practice these properties a little bit. And hopefully you guys will start to catch on, start to see these patterns emerging. What I suggest you do is these properties that I gave you, just go ahead and write them down. Or if you have them in your algebra book, just have that book open to that page and follow along, because you'll be referencing these properties that I just showed you. Okay, so here's our first problem, 2m squared times 2m cubed. So the first thing you want to note is that they're being multiplied. Okay, so everything's being multiplied together. So basically what we do, here I'll show you the longhand version and then we'll do the shortcut, is that you have 2 times m, there's your 2m squared, and then times 2 times m times m times m, and there is your 2m cubed. So here's your 2m cubed, and this is your 2m squared. Everything's being multiplied together. So then you're going to say, okay, 2 times 2, that equals 4. And then m times m times m times m times m, that's going to be m to the 5th. Okay, there's 5 of them. So now using our rule that we just learned is basically I'm saying this is 2 times 2 times m to the 2 plus 3. Okay, this is our a to the n times a to the b, or yeah, I guess that'll work, equals a to the n plus b. Okay, so there it is. There's your m squared, m cubed. You just kind of add them together. The constants that are attached to your variables here, they just multiply. You multiply those together. So then you get 2 times 2 is 4, and m to the 2 plus 3, that's 5. So there's our final answer, is 4m to the 5th power. Okay, using this rule that we just learned. Okay, so there's 2 ways we could handle this one. We could say that this is 2 times m to the 4 plus negative 3. Okay, there it is if we add them using our that property of adding them. Or we could say that this is 2 times m to the 4th divided by m to the cubed. Remember, if we get a negative exponent, we put that underneath. Put that underneath with this division sign here. This is your reciprocal. And then kind of cancel them out. So then you get 2 times m to the 4th, or excuse me, 2 times m to the 4 minus 3, which equals 2m. Same up here, you get 2m. So basically what you're looking at is 2 times m times m times m times m. There's your m to the 4th, and then here's your m cubed, m times m times m. If you know your rules here, you could just kind of cancel these out, and all you're left with is 2m. So there it is, kind of the thought process. There's 2 ways you could go through it. One way, you just notice that this is going to give you your reciprocal, so you could put that underneath could put that down below, or you could just do this process here where you just add them. So 4 plus -3. No matter what you do, you get the same answer as 2m. Okay, so here's our next problem. 4r to the -3 times 2r squared. Okay, so if we look at this portion of it, we're going to say that that equals 4 over r cubed. Okay, and then we're also multiplying that by 2r squared, which is basically 2r squared over 1. So then you're going to say 4 times 2r squared, that equals 8r squared. And then r cubed times 1 is r cubed. So now you have 8r, I always do this, 8r2 minus 3. So you have 8 to the r minus 1, which is just 8 over r. Another way to look at this, if I kind of write it out longhand, that's going to be 8 times r divided by r times r times r. Okay, here's your 8r squared written out all the way. Here's your r cubed. And you just kind of cancel them out. What you're left with is 8 over r. So there it is. There's this version of it. You could kind of switch these rules around, I guess, to figure out which way is quickest for you, whichever way you want to see it. You know, another way you could do is you could say that this equals 4 times 2 times r to the -3 plus 2. Okay, there's your r to the -3. Here's your r to the 2. Just adding those. Remember, you could do this addition rule as well. That'll still give you 8 to the r to the -1, which is just 8 over r. Okay, so there it is. A couple different ways to solve these. You can kind of mix and match these strategies. Whichever way you see just kind of jumps out at you, I guess, is the way to go. Okay, here we go. 4n to the 4 times 2n to the -3. We kind of do the same thing. So we're going to say that equals 4 times 2 times n to the 4 plus -3. So that equals 8 to the n to the first power. Another way to look at this is that this equals 4 times 2 times n to the 4th divided by n cubed. Okay, then we're saying that equals now 8 times n to the 4th minus 3 by using our subtraction rule. Okay, there's different ways you could go about solving these using the rules. So now we're going to say that's 8 to the n to the first power, just 8n. Okay, so here we used our reciprocal rule, bringing this negative exponent down. So this was one strategy. Going this way is one strategy. This was another strategy. Here's the addition. You're just adding the exponents. So they're being multiplied. You're just adding the exponents, but don't forget you're adding a negative number. Okay, you're adding a negative number. So here's one method to solve this one. Here's your second method. Okay, either way is good. Good to go. Okay, this one should be pretty quick. 2k to the 4th times 4k. So we're going to say that's 2 times 4 times k to the 4 plus 1. Remember, if you don't see any exponent, you're just going to automatically know that's to the first power. So we get our answer is 8k to the 5th. Okay, Okay, if there's no exponent, you don't see anything there, just automatically know in your mind that there's a 1 there. So there it is, 8k to the 5th. Okay, here we go, this one. Here I'm going to go ahead and do the reciprocal rule where we put it underneath the division sign. So we got 2x cubed. Put that. So this y to the negative 3, that's going to go down here, y cubed. And then times 2. But this x to the negative 1, that goes down here, x. And then times y cubed. So we get our answer, the 2 times the 2. That's going to give us 4 x cubed y cubed over y cubed x. Okay, this y cubed cancels out. What we're left with is 4x cubed over x. Okay, or 4x to the 3 minus 1, just 4x squared. Okay, we're just simplifying. We're simplifying by using our rules. Here, basically, I have 4 times x times x times x over x. Okay, this portion here is this. And I just cancel one of those. What I'm left with is 4 times x, or 4x squared. So there's our final answer, 4x squared. There's another way we could do this. Okay, so that's one strategy, by doing the reciprocal anytime you have the negative. Now, you're not taking this too long for the ride. You're not taking that too long for the ride. You're just taking this x. Just whatever's to the negative, that's what goes underneath. That 2, it just kind of stays there. It doesn't go along for the ride. So the only portion that's going underneath is the whatever's being raised. So long as they're being multiplied, whatever's being raised. So this is the only one going down. This is the only one going down there. So I'll show you another way to tackle this problem. Is by doing the addition rule. So now we're saying that this is 2 times 2. Okay, there's our 2. There's our other 2. And then we're going to say times x to the 3 plus minus 1. Okay. There's doing our addition rule. Since this x cubed is being multiplied, all these are being multiplied together. This x cubed is being multiplied by this x to the negative 1. I could go ahead and do our addition rule. And I could also do that with the y. So I could say this is y to the negative 3 plus 3. So what we're left with is we have 4 x cubed plus negative 1 is just x squared. 3 plus negative 1 is 2. Right, x squared. And then y to the negative 3 plus 3. So we're saying that that is y to the 0, which as we know equals 1. So what we're left with is 4x squared times 1, or just 4x squared. So there's your second way of solving this problem, by using our a to the m times a to the n equals a to the m plus n. Okay, the other version that we used was the a to the negative n equals 1 over a n. Okay, these are our two rules that we're using. Here's the rule we used in the first strategy. Here's the rule that we use in the second strategy. So you can kind of pick and choose which way you want to do these. Okay, 2y squared times 3x. This one should be pretty simple. All we're going to do is multiply these so we get 2 times 3 is 6, y squared x. That's a pretty quick and easy one. So basically what you have is 2 times y times 3 times x. Okay, 2 times 3, that gives us 6. Y squared x. Pretty quick and simple. Okay, here's our next one. 4v cubed times vu squared. So we're going to say that that equals 4 times v cubed plus 1 times u squared. So we get 4v to the 4th u squared. Okay, that one's pretty simple, pretty easy one. Remember here, your 3 plus 1, this plus 1 comes from this one here. So if you don't see anything above, you know that there's an invisible 1. It's just sitting there. So that's where we get this 1 from. So there it is, 4v to the 4th u squared. Okay, here's our next one. So what we can do, automatically we could say that that's going to be 4 times 3. We kind of bring those constants out. A cubed b squared. And then how about divide by a to the 4th b cubed. Okay, we could do something like that. So we're going to say that that equals 12 times a to the 3 minus 4 times b to the 2 minus 3. So that's going to be 12a to the negative 1, b to the negative 1, which equals 12 over ab. Okay, 12 over ab. There's our answer, 12 over ab. Okay, x squared y to the negative 4th times x cubed y squared. So we could say that this is x2 plus 3 times y to the negative 4 plus 2. So that equals x to the 5th times y to the negative 2. So that's going to be x to the 5th over y squared. Okay, x to the 5th over y squared. Okay, here we have x squared raised to the 0 power. So we know anything raised to the 0 power equals 1. And since this is closed in brackets, that means everything inside the brackets is being raised to the 0 power. So we're going to say that just equals 1. Now if I had something like x squared times y to the 0 power, that's just going to be x squared times 1, or just x squared. Okay, another way to look at this is the multiplication, where you say that this equals x to the 2 times 0, or just x to the 0. That also equals 1. Okay, so anything raised to the 0 equals 1. Okay, 2x squared, all that raised to the negative 4th power. So what we're going to do is we're just going to say that that equals to 1 divided by 2x squared to the 4th. Okay, just using our reciprocal rule. Okay, bringing that negative exponent down. And then we're going to say that this equals 1 over 2 to the 4th times x2 times 4. Okay, each one of these, remember this, if you have something being multiplied together, these are being multiplied together, that this exponent kind of distributes in. So we distribute here to the 2 to the 4th and x squared to the 4th. So then we get 1 over 2 to the 4th, that's 16, and then x to the 8th power. So 1 over 16 x to the 8th power. There's our answer. Okay, what about this one? 4r to the 0, all that raised to the 4th. We know anything raised to the 0 power equals 1. So we could say that this in actuality equals 4 raised to the 4th power. That r to the 0 just simply turns into a 1. Anything multiplied by 1 is itself. So it just kind of disappears, and what's left is the 4. So then we're going to say 4 raised to the 4th power. It's 4 times 4 times 4 times 4. So that's 16 times 16 is 256. Okay, 4a cubed, all that being squared. So we're going to say that this equals 4 squared times a to the 3 times 2. Okay, remember, if something's being raised to the power and that's being raised to the power, then we're multiplying them. Okay, this is a power being raised to another power. So we're multiplying. We're not doing the addition rule, we're doing the multiplication rule. Okay, so we know 4 squared is 16, and a 3 times 2 is 6. So there we go, 16 times a to the 6th. Okay, 3k to the 4th, all that being raised to the 4th. So we know that that's going to be 3 to the 4th times k to the 4 times 4. Okay, same thing we just did. Power being raised to the power means we're going to multiply them together. So 3 to the 4th, that equals 81. K to the 16th. Okay, there's our answer, 81 k to the 16th. Okay, 4 times xy, all that to the negative 1st power. Basically, this is a pretty simple one. We're just going to say that's 1 over 4xy. Okay, we just do our inverting. We're just going to drop that whole thing down. Remember, it's kind of like this. But that's the same thing as saying 4 to the xy. So there's our answer, 1 over 4xy. Okay, 2b to the 4th power, all that raised to negative 1. Similar to what we just did, we're going to say that this is 2b4. So we just take all of this and shove it underneath. Shove it down underneath the reciprocal. This is called your reciprocal. Okay, so for this one, we're going to go ahead and say that this equals x to the 2 times 2 times y to the negative 1 times 2. Okay, or just x to the 4th times y to the negative 2, which equals x to the 4th divided by y squared. Another way to look at this is, okay, so this is one method. Another way to look at this is we could say that this equals x squared over y, all of that squared. Basically doing the reciprocal first. And then our other rule where we say, remember this rule, a over b to the n equals a to the n over b to the n. So that's just saying x squared times 2 over y squared, or x to the 4th over y squared. So there's two approaches you could take to this. One is just go ahead and do the multiplication first, which is what you get here. Second way is do the reciprocal first and then do this rule here, this rule. So there it is, two different methods to get the same answer. Okay, so here we go, 2x to the 4th, y to the negative 3rd, all that raised to the negative 1st power. So we're going to go ahead and say that this is 2 to the negative 1st times x to the 4 times minus 1 times y to the negative 3 times minus 1. So we know we're going to have a reciprocal. And that 2 drops down below. 4 times negative 1 is negative 4, so we have x to the 4th. And y times negative 3, y raised to the negative 3 times negative 1 is just y raised to the positive 3. So that's going to remain up top. So what we get is y cubed over 2x to the 4th. Okay, another way of looking at this, so there's one method. Another way of looking at this is you could say that we could go ahead and do this negative exponent first. So we could say that this is going to be 1 over 2x to the 4th, y to the negative 3. Okay, then we could bring, since we know that this is a negative here, we could bring this whole this term up to the top. So now we could say that that equals y cubed over 2x to the 4th. So there's two ways you could tackle this. Once again, you kind of have a little variety in how you want to solve these. The first way, here we go, we just did the multiplication, and that's this whole way of doing it. Second way, we just bring everything underneath this sign here. We do the reciprocal. Here's your reciprocal. And then we bring this one back up to the top, because here you have a negative in the denominator. Anytime you see a negative, whatever it is, you just flip-flop it around this division sign. So there it is, two ways to get this problem done. Okay, 3m to the negative 2. We could say that that equals 1 over 3m cubed. That equals 1 over 3 cubed m cubed, or 1 over 9m cubed. Okay, pretty simple. Okay, r squared divided by 2r cubed. So we're going to say that that equals 1/2 times r to the 2 minus 3. So we get 1/2 times r to the negative 1. That's 1/2 times 1 over r, or just 1 over 2r. Okay, 1 over 2r. So basically what you have on top is you have r times r, and you have a 2 times r times r times r. Okay. Using our rules of our fractions, you can kind of cancel these out. All you're left with is a 1 on top and a 2r on the bottom. So where did this 1/2 come from? Right here. Here's your 1. There's always an invisible 1. A lot of people don't realize there's a lot of invisible 1s here. So there's an invisible 1. 1 times r squared. Because any number times 1 is itself. So you always have a 1. So there it is. There's your 1/2. 1/2 times r. Everything's being multiplied. So you could say that this is 1/2. Okay. That's where that comes from. Okay, x to the negative 1 divided by 4x to the 4th. So we know we could bring that x to the negative 1 below. So here we got a reciprocal thing. 4x to the 4th times x. There's the x. I just brought it down. So that's going to equal 1 times 4x to the 4th plus 1. Okay, there's another invisible 1 hanging out right there. So what do we get? 1 over 4x to the 5th. Okay, 3n to the 4th divided by 3n cubed. So we're going to say that equals 3 over 3 times n to the 4 minus 3. So 3 over 3, that equals 1. So 1 times n to the 4 minus 3 is just n to the first power, or just n. So we get our answer is just n. Okay, whenever you see something like this, if everything's being multiplied together, you can kind of bring out that fraction and then just multiply it by whatever's left over. So there's your 3 over 3. It's just equal to 1. Okay, m to the 4th divided by 2m to the 4th. Well, we know right off the bat this one should be pretty simple. You could just kind of cross those out. So what you're left with is 1/2. Right? Why could I do that? Because, you know, m times m times m times m. There's your m to the 4th times 2 times m to the 4th. And you just start crossing these out. Okay, just using your rules from fractions. All you're left with is 1/2. So there's your answer, 1/2. Okay, 3m to the negative 4th divided by m cubed. So we're going to say that this equals 3 over m cubed times m to the 4th. Just taking this negative exponent and bringing it down, doing the reciprocal rule. So then we get that this equals to 3 over m to the 3 plus 4. Remember, they're being multiplied together, so we add. So our answer equals 3 over m to the 7th. Another way to do this is we could go ahead and do our other rule where we say that this equals 3 to the m to the minus 4 minus 3, right? Since it's being divided, you subtract. So it's being divided, you're going to subtract. So you get a negative number, subtract another number. So that equals 3 to the m to the negative 7th. Or just 3 over m to the 7th. Okay, two ways you could approach this. Okay, 2x to the 4th, y to the negative 4th, z to the negative 3rd, divided by all this other stuff, 3x squared, y to the negative 3rd, z to the 4th. So we're going to say that that's 2/3 times x to the 4 minus 2, y to the negative 4 minus a minus 3, and those are being multiplied, and z to the negative 3 minus 4. So we get 2/3 x squared, y to the first power, negative 4 minus a minus 3. Actually, that's going to be a negative 1. Negative 4 minus a minus 3 is saying negative 4 plus 3. Negative 4 plus 3 is negative 1. And then z to the negative 3 minus 4 is going to be z to the negative 7th. So we get our answer as 2 over 3. X squared goes on top because the exponent is positive. The y goes underneath because it's negative exponent. And the z to the 7th goes underneath because it is also a negative exponent. So here's our answer, 2x squared, 3y, z to the 7th. Okay, so here we go, 4x to the 0. So that's saying 4 times 1. So we're just going to say 4. And y to the negative 2. We could bring that down. And there's also a 4x down here. And there's a z cubed on top. Okay, so all we did here is we switched this to a 1. It kind of goes away since everything's being multiplied. And the y to the negative 2 just goes down reciprocal. So now at this point, what we could do is we could cross out this 4 and this 4, and what we're left with is z cubed on top and a y squared x on the bottom. Here's our answer, z cubed over y squared x. Okay, so first thing we could do is we could go ahead and say that there's a 2/3, and that's going to be times h cubed times j to the -3 minus 1 times k to the 4 minus 1. So we get 2/3 times h cubed times -3 minus 1 is j to the -4th, and then k, 4 minus 1 is just going to be k cubed. So it looks like we only have one of these is going to be in the denominator along with this 3. So we're going to say that this is going to be 2h cubed k cubed divided by 3j to the 4th. Okay, so what we have is 4/3 times m to the 4 minus 2 times n to the 3 minus 2 times p to the 3 minus 4. So we get 4/3 times m squared times n to the first power times p to the -1. So we're going to say that's 4m squared n divided by 3p. Okay, here we go. So it looks like we have a 3 times x cubed minus a minus 4 times y to the -1 minus 0 times z to the -1 minus 0. So what we're left with is 3 x to the 7th. 3 minus a minus 4 is the same as 3 plus 4. That's x to the 7th. Times y to the -1, z to the -1. So we're going to say that's 3x to the 7th divided by yz. Okay, if you made it to the end of the video, I just want to thank you for watching. Please like and comment, and if you want to see more of these, go ahead and share with your friends, and don't forget to subscribe to my channel. Thanks for watching.